Hey everybody, and welcome back to Kerbal Space Program RP-0. This is a Twitch recap from 2 weeks ago, because I took last week off to go on vacation for my birthday, and had a very lovely time, but I'm also very eager to get back into the swing of things and get some quality kerbling done, or some subpar kerbling done. Anyway, this is the top secret project that I have been alluding to for a little while now. It's investigating the viability of reusable systems for landing crews on Mars. And this is an initial prototype, not a very good one, I have to say. But it is just kind of spitballing, throwing some ideas around, seeing if we could bleed off enough speed with drag alone to save us a whole lot of fuel on descent. We do have every intention on touching down using these engines. We'll touch on that a little bit later, but aerodynamics at Mars are a little weird in that they're very. There's not a whole lot of atmosphere until suddenly there's just enough to really mess with you. But there is enough to get some a solid drag coefficient going to ease landing a whole lot, but as you go up in tonnage a bunch, you need a larger and larger surface area to make that drag matter. And so I was kind of investigating if that surface area could be built onto wings, and if we could make a vertical takeoff and I don't know, short landing spacecraft capable of hopefully being a reusable system for landing on Mars. I did spend a lot of time trying to balance the fuel load out and um, get some of the things worked out for this particular system. Unfortunately, there was still a whole hell of a lot of work to do. So this is actually my very first attempt at trying to bring it in through the atmosphere and just kind of seeing how it would behave after spending a very large amount of time working out those rotatorons to tilt those engines. Now it has basically three settings: full aft, which would be normal flight. This is about 140 degrees forward, which would be entry and descent mode, and then 90 degrees down, or yeah, straight down. Which would be for the final bits of landing and the first initial section of takeoff. So, what we needed to find out was how much drag we could induce, and really, we're looking to make this so that we can do a solid flight down and then a solid flight up without having to refuel and without having to service any parts. Now, the drawback to a reusable system in this case is our biggest limiting factor: runtime on the engines. These engines, which are the experimental lander engine that were developed for our Mars program many years ago, are rated for about 8 minutes of runtime, which doesn't leave us a whole lot of overhead for this particular design, which basically means one flight down, one flight up, with a little bit of top off on fuel, and you're on top of your maximum runtime. I was hoping that we could bring engines, spare engines, down with us, but we'll touch in on that a little bit later, because with the Kerbal attachment system, we can have a Kerbal switch engines in situ, or even better would be in orbit. But as long as we have a trusty DeWalt cordless drill on hand, we can really do either. So that's really like the backbone to making a reusable system for Mars landings viable. Now, the targeted part of Mars landings is going to be a little bit more difficult, but if you remember our last Mars base, where we had to try to target drop some what would have been food resupplies, but then turned into spare engine parts supply drops, we weren't actually all that bad with our targeted landings, so I think we might be able to figure it out, although relying on a drag and draft model instead of an all engines all the time down model does complicate things a little bit, but I think with enough trial runs we might be able to figure it out. And yeah, it's right about I don't know, 50 some odd kilometers altitude, where there was just magically enough air around the spacecraft to make it horrendously unstable. I think a lot of it has to do with the extra drag and the weight shift from rotating the engines around. So I did try to tuck those back in to see if maybe we couldn't make some kind of recovery here. But I think it was my hubris not checking with FAR to see how angry FAR was going to be. And I kind of assumed with big, broad thrusters and a lot of them, we could just muscle through some aerodynamic instability. Not the case. Not the case at all. I did try to fire the engines in full aft braking, um, which showed another weakness of this design, and that the Rototrons are not really meant to deal with this much torque being applied to them. The engine nacelles kind of wobbled and flapped around all willy-nilly, which is a absolute no-no if you want to do controlled descent or controlled ascent. You can't have your engines flopping around. And this is a problem we had when we were doing the big Artemis test run that eventually became the Chestnut and the BPR projects in their final versions, is that robotic parts from Infernal Robotics, just not that stable. Now there is a solution to this, and it is basically to edit the config file for the robotic parts and increase their base mass. That unfortunately is not really something I want to do, but to satisfy the want for all the explosions, we're just going to watch that pile into the ground and kill all the simulated Kerbals before jumping back into the VAB to try to salvage some of this. So the very first thing we're going to do is pull out FAR and see that everything is red. But we are also looking at Earth as the home planet, and the altitudes are a little off. So I initially tried to adjust things for a nice, I don't know, analog of what would be at Mars. But then I was told by chat that I needed to make the spacecraft point up so that it would take into account my direct actual line of travel before opening up FAR and trying to deal with these things. So the first thing I really kind of wanted to investigate was being able to haul an engine along with us, and that chews up like most of our cargo bay, which is not really a huge problem, but we can only fit one engine inside this massive KAS container. So if we wanted to take two engines, which we would need to do a full swap out, we would need to bring two of these, and that is our entire cargo bay, which means cargo bay becomes essentially, useless-ish. We still do need to bring down parts, and it'd be nice to have like a rover or, some other things other than just a replacement engine, just in case. But we'll cross that bridge when we know it's actually a viable system that might need engine replacements. So the first step in trying to correct some of the wibble wobbles was to just use a tweak scale to size up the rototrons, which of course kick the nacelles out of position, but we'll just go ahead and use our handy move tool to try to get those back someplace close to where they are, and then run another FAR scan, which doesn't look very good. But again, these numbers are for Earth at Mach 12. We can actually switch this to Mars, which is something I guess I had never noticed before. So we'll just go ahead and plug in the data for where we lost control before. And yeah, the number's not great, but not terrible either. But we will be coming across some other problems. Basically, there's a lot of instability across the yaw axis, and so I just wanted to see what we could do to try to remedy some of that. We'll rerun our sweep derivatives. The numbers do improve a little bit, especially after removing those canards, but they're still not great. So we'll just go back to tried and true and add more thrusters, because even when more boosters isn't a thing, more RCS ports certainly can be, especially in this case. But I doubt the abilities of these things to muscle past even the very rare atmosphere at Mars. So with all of those changes done and made, we'll drop into another simulation starting us out in orbit of Mars and come to a new problem. The scaled up rototrons no longer rotate the engines. We get the nice things are rotating sound, but no actual articulation on the engine nacelles at all, which is, well, not good by any means. But we still do have an opportunity to test our atmospheric characteristics and see if some of these changes we made will help our stability, especially in the lower atmosphere. We're generating a lot of drag and maybe even some lift is the primary purpose of this spacecraft design. If it can slow itself down to just a couple hundred meters per second, then an all-engine landing after that might actually be feasible, provided, of course, we can actually rotate these engines, although a complete redesign is not out of the picture at this point, and we'll certainly touch on that as things go on. But as we start to get into actual atmosphere, even in the nighttime side here at Mars, things do behave a whole lot better. Now, we also don't have the engine nacelles moved out of place, which may be a contributing factor to our stability. A smart person would have rescaled or rotated the engines in the VAB to see if that changed FAR's sweep calculations into something less fun. Maybe more fun to fly, but certainly more stressful and less predictable. That might be the word I was looking for. But even as we get into some of the lower atmospheres, we are able to keep our nose up and keep things mostly under control. And I was paying a lot of attention to our vertical speed indicator. And for a good bit of our descent, we were actually shedding our rate of vertical speed, meaning that we were actually generating lift and starting to fall towards the surface slower. You can see it now down into the 30 somethings, although once we get below a certain speed, because you'll notice we're not shedding a whole lot of speed, we are, however, falling, and but our rate of how fast we're falling is decreasing. We just don't start actually decelerating until much lower in the atmosphere than what I'm used to. But of course, everything I've done so far has been a propulsive landing with parachute assist, relying on a nice long engine burn high in the atmosphere to make sure we slow ourselves down enough to light those or to deploy those parachutes that will do the last hard tug of deceleration before lighting the engines again and touching down. And while it has worked 1 out of 3 times successfully, all due 2 failures due to pilot error, not because the system was bad, but because I'm just not that good, really, especially under these more high stress situations. But I'm working on it. I'm going to try to get better, and hopefully a system that doesn't rely so much on timed precision burns to put something safely on the ground might be more my speed. But we'll definitely see how well we can make something a little more efficient work out for us. But like I said, if we want to have a single stage descent and up, even pseudo reusable system, we need to start offloading more of the deceleration onto Mars's atmosphere and less on the engine bells. So we will be investigating how to pursue some of these things for quite a while now. I think I opened the cargo bay to see if it wouldn't generate more drag, as our vertical speed has started picking up a whole lot. And there was a failed attempt to ignite the engines and maybe get ourselves into a position where we might even be able to tail land this thing. What I had not noticed was the yellow indicator over there on the side, indicating that we have a loss of performance on one of our engines, meaning this flight, even though it has like 30 seconds of runtime on one of the engines, is now, well, everyone's going to die, and there's nothing we can do to stop it, because, well, if you do get these engines to fire up, yeah, so that's something worth considering. We will again jump back into the VAB and try to make some changes to see if maybe just reattaching everything or rerouting all the things to the parts in which they're supposed to be attached, instead of just right-clicking, hitting tweak scale, and moving on from there, might help us with our Rotor Tron problem. So because we need to replace the engines in situ, we're using that little base plate to give the Kerbals a nice solid node on which to attach the engines. We're also going to reduce the fuel load in the nacelles themselves to reduce the mass that is in the wings, and then up some of the fuel tanks in some of our wing location tanks hopefully keep the balance. Now, these Rototrons do work in the VAB. They work great in the VAB. So we'll just queue up another simulation, spend a pile of money, and really, well, I should have not done this one in Mars orbit because, yeah, Rototrons not rotating again. And that seemingly would be the crux of this entire thing. Because, yeah, you can move them all you want here in the VAB. Everything seems to just move around just fine. But when you get it outside, well, yeah, there's nothing. So I thought maybe it was because the engine nacelle was clipping through the entire part of the Rototron. So we'll adjust that out. Check for clearances. They're not great, but at this point it really doesn't matter. We'll throw some launch clamps on it. We'll adjust our simulation to Earth, reduce the time a whole lot in an attempt to actually not spend a ludicrous amount of money. Invert the axis, because I forgot to do that before, and no rotation yet again. So I think tweak scaling on robotic parts for the hinges seems to work great. I've done that for rovers and wheeled and tracked things all the time, and everything just seems to work out pretty well there. They're not the most stable connection, but they do work. Rototrons, however, just does not seem to work at all. So just as an experiment, we'll scale them back down to their original size, jump outside on another simulation, and yeah, hey, look at that. Everything rotates. They rotate just fine, but fire up those engines and, oh man, they go all willy-nilly. In full aft, they're not that bad. But yeah, they do definitely, it's not a viable system, is basically, unless we can get a much more solid way of connecting these things, not going to be great. So, well, I would try, again, just to reduce the mass load on the Rototrons, see how things would shape up that way. If maybe there was some viable alternative here, but I just don't know if a tilt wing design, or not a tilt wing, I'm sorry, a tiltable engine, opposable engine design like I would really like in this case is going to be a viable thing, and that makes me really, really, really sad. So I would try one last attempt here to place the Rototron, verify that it's in the right place, scale it up before doing anything else to it, and then of course going through all the funness of attaching the engine nacelles through a nice strong attachment node, making sure that they were attached to the correct side of the Rototron, reattaching the engines, reattaching the wing segments, not really worrying too much about how things fit, finish, or look. Yep, everything rotates fine here in the VAB. You get it outside, nothing. No rotation at all. And that does make me real sad because, well, I don't think we can make this work, but we will be trying some other designs in the near future. No worries there. That's going to do it for this one, everyone. Thank you so much for hanging out. I really do appreciate it, and I will see all of you in the next one. So until then, see you later.